Okay, so now we're going to be talking about why atoms react. And just to remind you about what we're looking at here, we've already done this where we've listed the subatomic particles. We've defined the following terms, which is valence shell. And as a reminder, you notice that electrons are traveling around this nucleus in the valence shell. So that's the path that electrons travel around that nucleus. Okay. Now, let's look at this picture a little bit closer up here. So what we have is that we've got two atoms shown here. Okay, we've got one on your left side and then one on your right side. Okay, now here we've got this nucleus in the center, over here the nucleus in the center. Now let's look at these shells around the electrons. Now you may notice that you see two series of lines. Well, here's one line, and this is the first valence shell. It turns out it's actually closest to that nucleus. You then have a second valence shell, and I like to think of these almost as racetracks around the middle of something. So you have a second valence shell that also circles around this nucleus. Okay? And in reality, we could end up with a third valence shell as well that we could draw right out here outside as well, and that would be the third valence shell. Okay. Now, there's some really important things that you need to understand about these different valence shells. Each one of these has a maximum number of electrons that you can fit into each shell. So here on the first shell, it turns out that we have 1, 2, and that is the maximum number that we can fit. Okay. If we look here at this second shell, it also has a maximum, and that maximum is 8. Okay. Now, if you are going here to the notes packet and would like to follow along, this is the part that we're going to be filling in right here. And the maximum number of electrons in the first valence shell is 2. The maximum number in the second valence shell is 8. And then for the third valence shell, we also see a maximum of 8. Now this here is asking for proximity to the nucleus. That just means how close is this valence shell, this racetrack, how close is it to the nucleus? Well, here you can see the first shell is closest to the nucleus. Second shell is just outside of that. And as a reminder, if we were going to draw that third shell, we would have drawn it way out here on the outside. Okay? All right. So if you're going to fill that in here, proximity to the nucleus, closest in the middle, and here for the third shell, it's going to be farthest away. Now, if you're taking chemistry, you'll probably learn that there are more than just 3 valence shells. There are many more, but for our purposes, we're just going to deal with these first 3. Okay? So, here's this question. Why do atoms react? Okay? And this is an important question, and it has to do with how many electrons are in each shell. So, atoms want each shell to be either completely full or completely empty. And what a reaction means is that means that they will either gain, lose, or share electrons to get their shells completely full or completely empty. Okay, so let's look at each of these atoms and see if they're going to react. Okay, so let's look here at this first shell right here, and we can ask ourselves, is this first shell completely full? Well, the maximum number is 2, and we can count them. 1, 2. Well, first shell completely full, no issues. Okay. Well, what about this second shell here? Maximum number it can hold is 8. And how many does it have? Well, only 1. So what that means is that it's either got to gain 7 or lose 1 electron. This shell needs to be either completely full or completely empty. And it turns out it's a lot easier just to lose 1 than it is to try and find and steal 7 from somewhere. Okay, so that's how this atom will react. Now let's look at this next atom. We start the same way. First, we look at the first shell. We count electrons. 1, 2, completely full. So now let's look at the second shell. Let's count electrons. 1, 2, 3, 4, 5, 6, 7, 8. The maximum it can hold is 8, and it has 8. Awesome. So it's not going to react based on the second shell. So what about this third shell out here? How many electrons does it have? None. So that third shell is completely empty. So this atom here will react by losing 1 electron. This atom over here will not react because all of its shells are either completely full in the case of the first 2, or the third one is completely empty. Okay, so what I would then like for you to do, which is what I suggest, is that you now move to some practice problems here, right in this area, for determining how these different atoms will react. Now I've given you some extra information. Here I say an atom has 1 proton and 1 electron. Well, we said, why do atoms react? Their valence shells are either completely full, are either not completely full or not completely empty. Okay, completely empty. Okay, so the thing you need to keep in mind here is that they're reacting based on electrons. So in this problem right here, it tells you protons and electrons, but it asks you how will it react. So what do you care about? Well, you just care about electrons. And as a tip at the bottom of our sheet here, it reminds you that the reactions we discuss in this course, atoms react only by gaining or losing electrons, not protons or neutrons. Okay, in chemistry you might learn about some things that are a little more complicated than that. But for our purposes, we're just talking about electrons. So let's look here. So if we just care about 1 electron, well, where do we put this? We would put this in the first shell. And what's the maximum that can hold? Well, it can hold a maximum of 2 electrons. So is it completely full? No. Is it completely empty? No. So how will it react? Well, it either has to gain an electron or lose 1. Okay? And so we know from observation that in fact it most of the time will lose 1. Okay? So what I'd like for you to do is I'd like for you to take these next 2 questions and see if you can fill in the blanks. I want you to look at how many electrons this has. Fill in your valence shells starting with the first one first, and then move the remaining electrons to the next one, and see what you end up with. Are your shells completely full, completely empty? And see how many will it lose or gain. And then my suggestion is that you email your instructor and see, are you correct? Does that make sense?